Yeah, so just jump into who we are since we're running a little time. So my name's Erika Noerenberg. I'm a threat researcher at Carbon Black. I mostly do malware analysis and reverse engineering. And you can find me on Twitter at Guttertroll.
And I'm Josh. I'm a senior security engineer at Trail of Bits. And you can find me at Josh_Watson on Twitter.
Yeah, so we decided to switch shirts. I'm the one that
I've gotten so many talks, people talking to me about that.
I keep asking him if he works at Carbon Block, but that's actually so. You can't see the Trail of Bits these days. Yeah. So just quick, we're going to talk about kind of the Shlayers stuff. It was something that I was researching recently. I'm going to talk about how that started and what kind of started all of this whole thing. And then just a really quick overview and technical analysis of Shlayers, just kind of highlighting the interesting bits. I'm not going to go into a lot of depth because I want to make sure we have a lot of time for the demos of the tools that Josh has written. But I did do a talk on it a couple weeks ago at NOLACon that goes into a little bit more depth, and I put that on, I just tweeted it. So if anybody actually wants, if I get through it too fast, you can do that. And then Josh is going to talk about some reversing Objective-C in general, and then the binary ninja and the tools, and do some demos. And then we'll have hopefully a couple minutes for question and answer. But anyway, how it all started. So I was sitting on my couch back in November, and I got a Slack from my coworker Jimmy, and he's like, "Hey, he's a home brewer, and he's like, I was looking for this stout recipe, and this thing popped up, and it's asking me to install Flash." So I thought that was probably kind of odd. So I was like, "Oh, great! I'm going to pull this down and see what's going on." So of course it's malware, and the whole site was completely popped. Not surprising. We looked into it. It was hosted by GoDaddy. We were trying to find, who can we report abuse, blah, blah, blah. Well, the domain was expired. So there was really no way to get this thing and notify anybody. So it's been sitting there. It's still infected, but things have changed a little bit. But yeah, so this beer forum basically got, it's been serving out Flash malware. But this is what kind of started out going down, digging a hole, getting a little deeper. So then in January, we didn't really have a lot of time. I had a lot of, we're a small team, so you've got stuff coming at you all the time if you do malware analysis, or threat stuff. So it kind of just sat there for a while. And then I was doing some work with Swimtail back in December, and I started looking at it again, and I was like, oh my God, I found this post from Phil Stokes, and I was like, it was talking about this gatekeeper bypass, and I thought it was interesting. It just came up in my feed, and I was like, oh my God, this is my script that I found back, a month ago, and that looks really familiar. And it turns out, so this was the script that was in the stuff that I had pulled down, and this is a clip from his website. I was like, that is almost the identical script. And you can see, like, the other one was marsupials.zip. This one was kittens.zip. There was porcupines.zip, all of these things. So this was one version of it that I found. But I was like, oh my God, this is this article about Windtail that I've been kind of looking at for a couple months. Maybe this thing is bigger than just adware. Because when we first saw it, it's like, oh, Flash stuff. It's installing, adware and blah, blah. Maybe this is actually something bigger. But so down the rabbit hole we went. And I'm like, oh, yay, maybe this is actually something exciting. Oops, I lost the thing. But basically, so when I started digging into it, then I actually found, So basically, at this point, Double Docs was this beer site. We're like, let's just pull down all the things, get everything we can. And so Greg wrote a script using Selenium to basically automatically load the site, pull down the screenshots, the URL, any payloads that are there. And this worked for a while, but then they started changing the site. And so they would move the download links around. They would detect IP ranges. So we started having to use VPN hopping, putting in delays and all these things. And so it started working less and less. But at this point, we had a little bit more information. We had a bunch of samples. And we actually got like about 15. I'll talk about that a little bit later. But just right off the bat, I had like 15 samples to go off of in the first couple hours, just running this script. So we're like, great, we found this awesome new thing. We got to give it a name, right? Because it's never been seen before, right? So I was talking with my coworker, Brian Baskin. Some of you probably follow him on Twitter, but we were having this heated debate about IPAs because people, you either hate them or you love them. People are very passionate about it. And since the initial site was Double Docs, it was like, well, let's just mess with Baskin and call it Double IPA. So yeah, that's how that started. But as we started looking into it more, I was like, actually, I've found this article, and I think this thing is called Shlayers. I think it's actually been around for a while. So this is nothing new. We didn't stumble on anything exciting at all. And yeah, then I found the Intego article from the original researchers back in February of last year. And it matched up. I was like, yeah, I'm kind of bummed that we can't use this double IPA name because that was kind of fun. But apparently this thing is Shlayers, so oh well. So I'm going to quickly just go over the overview. Yeah, just want to make sure we got lots of time for demos. Just a quick overview and technical stuff about this malware. Like I said before, the Intego researchers back in January of 2018 had found these things and researched it. We stumbled on some more. And actually, as I was writing this talk, I was going through my repository of Mac malware, and I found this giant folder full of Mac adware that I hadn't dug into at all. And I was like, oh, this is funny. And I found this back in June or something of last year. Hadn't looked at it at all. I opened one up and I'm like, this is Shlayers. I've been sitting on this for like 6 months. It's great. But yeah, it's the life of malware. So anyway, but in November is when we actually started kind of looking at it off and on. And then once we started seeing a bunch of infections in February, we're like, we need to dig deeper into this, and because there are a bunch of customers that are infected, and we weren't really expecting that in the numbers that we saw. So that's when we started. We really need to dig into this and look into it. But as we did, we discovered this privilege escalation technique that Patrick had actually talked about at DEF CON 25. And it's a really great video. But my coworker Jimmy, who had found the site initially, was actually doing a lot of work with MITRE ATT&CK, the MITRE ATT&CK framework at the time. And he was like, you know what, I can't find an actual technique in the MITRE framework that describes this accurately. And so he contacted the guys at MITRE, and we wrote up a kind of a description, like a page-long description of what this technique is and how it works and things like that. And so they've actually accepted that into the framework, so there'll be a new TID for it. It hasn't been released yet, but they were waiting on some things from us, probably this month, I'm guessing. But it'll be included in that framework now. So back to the sample collection. Like I said, my coworker had done this script to automate the detection and download of these samples. And you can see this is from his script here. He basically detects the page and says, let's download all this stuff. If it fails, if they detect, basically what they started doing after a couple of months, they're starting to get smarter. Is that if we detect that we think that you're doing analysis or something, we're going to redirect you to this www.9.doubledocs.com, which is like one of these dummy pages. You've probably seen them before. If you enter your search terms wrong or something, it's like this kind of fake looking page that seems to have your search terms, but it's really not what you're looking for. And so this is an initial part. This is all the samples that we collected, like just in the first run of this. And so we had about 15 unique samples, but as you can see, there were 3 hashes. It's not readable, but basically these 3 files are the exact same hash, but different file names and different delivery methods. So these are different pages that are serving out the same hashes. So there were some repeats, but they're changing the pages on each one so that it looks different. And this might actually work. No, it's not going to work. Basically, I just had a demo of the redirect from this site. But so just briefly about the distribution, like I said, we discovered it on the homebrewing site. The whole operation, basically, there's 2 methods. One of them was hijacking these expired domains, which is the one that we found. The other common one is being bundled with torrent files. So somebody goes to download a cracked copy of Photoshop, and they actually get, Schlayer instead. Some of them will actually install the actual program, the real program afterwards, which I discovered was pretty funny with one of the Flash updates. You go through the fake Flash update to install Schlayer, and it says install complete, and then the Flash updater pops up and says install Flash, and you go back through it again. So it's like, okay. So yeah, but most of them, again, were DMGs, PKG files, ISOs, or zips, and then again in the torrent files. When I was looking into the domain, I noticed that in the source there was some CSS from this parkingcrew.net, and I didn't know anything about these domainer sites, but basically there are people that you can pay them to park domains for the purposes of these kind of things, so that you can put your ads on them and things. And so I was talking to somebody after the first time I gave this talk. He was from VeriSign, and they said, yeah, domains like or services like GoDaddy, we give them lists of these parked or expired domains that are being abused on a regular basis. I mean, lists and lists and lists of them. But it's up to them to actually do something about it. So what incentive do they actually have to do anything about it? Not a lot. So these things still, persist, basically. I just want to give a couple of quick examples of some of these sites. This one I liked because it's a very good example of social engineering. You can see that it's taken it gives the user their actual version of Mac. So it detected that my system was running Mojave, and so it puts it up there. This section right here is the only part of this page that is not legitimate. Everything else on this page is mirrored exactly from Apple. So this buy AppleCare, if you click buy now, it's actually going to take you to buy AppleCare, for real. These up here, it's going to take you to the same thing the Apple site would. So very good social engineering. Your typical user is probably not going to think too much of this, given that so many of those links. Here's just some examples of different versions of these things that are serving this out. So that's just a few of them. So basically these are, it's the same packages, but they're just kind of showing it in different ways, so your user's not going to the same site and seeing the same thing again. And it's redirecting to something different. Some of these are Flash updates, some of them are these web extensions. And you'll notice that this is actually the Chrome store here. This is actually chrome.google.com, which I thought was odd, but I didn't have time to look into the Chrome extensions. I was still focusing on malware. So I kind of skipped over that. And I thought, well, then one day I'm doing some stuff in my VM, and I go to move this window, and I'm like, oh, that's just a little Chrome window on top of doubledocs.com. It's just making it look like it and hoping that you're going to click on the actual malicious link below instead of the actual legitimate extension up here. So I thought that was pretty funny. Some of them had a bundled crypto mining component, so this is just a quick. You can see where once,
that happens sometimes.
Yeah, you can see this CPU spike here when that page is loaded, basically. And another way that we saw it was they must be buying AdWords, I guess, because on some links, there was one my other coworker, Casey, he said, I was searching for Python 7-zip extract, and like the third result was a Schlayer link. My other former coworker, Adam, he sent me this one day, and he's like, hey, I was just looking at my name, and look at this link down here, and sure enough, took me to a Flash update serving out Schlayer. So a lot of different ways of distribution, so it's clearly a very large operation. In addition to that, which I'll talk about a little bit, they register legitimate Apple developer IDs and sign everything with legitimate certs. So it gets past, it's just another level of the social engineering anyway. So I just want to run through one quick example of one of these. So this is going to be a DMG file. Basically, there's a cascade of scripts that run. One script decodes or decrypts the next, which decodes the next, which decodes the next, which finally downloads the payload and installs it. And it escalates privileges, so it runs as sudo, gains complete root on the system, and as I said before, these are signed with valid developer IDs. So So here's an example of the first encoded script. So basically, you've got a giant thing of base64 encoded and SSL encrypted data, which decodes into the second script. Basically, you've got this OpenSSL encode base64, AES 256 CBC, and there's a password here, which is also interesting. This is hard-coded into each sample and varies with each sample. Another former friend of mine that had been tracking this said he had been looking at it, and it seems to be based on a timestamp, which tracks with, as I've been looking at it over the last like 4 or 5 months. These things are, increasing as you would have a timestamp, kind of. It's getting louder.
Yeah.
So this is an example of the second script that's decoded. So this is more of kind of a shell script here. Again, you've got another chunk of base64. This one is not encrypted, it's just base64 encoded. And then they actually use XXD, which if you're not familiar with XXD, it's a Linux or BSD-based command line hex editing tool. And so they're using that to format and print out the third script. So here's an example of the third script, which is just basically a straight shell script. I've highlighted down here, this is the curl command that they use to download the final payload. Basically, they build this URL with some data from the system, and then do a curl with these kind of unusual command line arguments of F0L. I'm not going to go into a lot of detail, but basically it's forcing HTTP 1.1, which is kind of odd. And L, I think, is follow redirect, or maybe, yeah, one of them is follow redirects and use and force HTTP 1.1. So that was actually one of our best behavioral indicators for finding this in environments. Using that alone, just curl in general with those specific command line arguments was a very, very high fidelity indicator that pointed to almost entirely Schlayer. And just a bigger look of this, one of these sample URLs. We've got basically the C we're calling a campaign identifier. It's not unique. They are clustered. We started to run some analytics on, is this like all targeting one customer, or is there some sort of connection between those? It doesn't seem to be. I think it's just a bundle of one batch that's created by them. And then the U is a unique ID for the system, and this is based on IO platform UUID. Again, the second one is another unique ID that's based just on the command line UUID gen tool. And then the macOS version with patch level. And then that encryption key, which is hard-coded, like I said before. This is that same thing that's used in that first script. So again, this didn't update. No. All right, well, anyway, I made this a little bit bigger right before. This is actually just a clip from a screenshot from our CB defense tool, but I just wanted to use this because it actually shows you this file. The app is signed by Dominguez Wawa. So yeah, so this is one of the valid developer IDs, Dominguez Wawa. And then again, down here, when the curl command is executed, you can see that password is used. The privilege escalation, basically it's running sudo, and it's invoking security off trampoline using this escalation technique that I talked about earlier. Authorization execute with privileges. So this is a screenshot from Patrick's talk at DEF CON. Called Death by 1,000 Installers, and very, very good talk. I would definitely recommend it. I'm not going to go into detail on this because he does a really good job explaining it, but I really liked this graphic because it really does a good job of kind of showing you what happens. So basically this API call, which is deprecated now, but so Apple deprecated this and made a safer version of it, but it turns out that it's kind of hard to implement, and so most developers are actually just still using this deprecated API because it still works. And so they can't really take it away because it would break a lot of things. So, but anyway, this will still, even though they can get around some things with this API calling security off trampoline in order to escalate. The user does still have to authenticate. But like I said, this comes down to social engineering, and the techniques are pretty good, and a lot of users still fall for it because they're installing something. And when you're installing something, you're expecting to have to authenticate most of the time. So it works. Let's do this. So we'll pass this off to Josh to talk about some Objective-C reversing.
All right. So yeah, we started off talking about doing all of this for Shlayers, and I'm going to just kind of go over real quick what Objective-C looks like in case there's anybody in here that hasn't actually tried to write an Objective-C before. So it's a lot different looking than regular C. It has these like interface and end, and the implementation details are wrapped in implementation things. The functions start with like minuses for methods and stuff. It's very interesting. And then this is what it looks like if you're actually writing some. So it looks a lot different than your normal C. And it doesn't really stop being different there, because when you get down to the assembly level, on the left side, it's kind of what C and C++ looks like when you're calling a method. You pass in, like, say, your class, this pointer into RDI, and then ESI is just going to be some parameter. But in Objective-C, you actually you still pass in your object pointer, but then RSI, your second argument, is actually a selector, which is a string of the name of the method that you're going to call, and then it passes in the parameters after that. And so, as you can imagine, this looks kind of crappy in your typical disassemblers like IDA. You have all of your your parameters here, then you've got your selectors up here, and then it calls this Objective-C message send instead of the actual method. And the problem with this is also in the decompiled version, you don't really get the calls like you would expect. It kind of has like objective message send for alloc, and objective message send stret, which returns like a structure and things. So it's a little hard to figure out like what's actually happening here, particularly because since the methods themselves aren't called, your standard disassemblers don't actually have any sort of cross-references. The best you get is a pointer to this method structure that actually holds information about the function, at which point then you can kind of like find the pointer to the function there and then get to it, which is just a hassle. Hopper's a little bit better in their decompiled view. You can see the calls, but you'll also notice that around here somewhere, I gave this is an older version that I gave Erika. I don't have the Objective-C message send stret in this one, so they don't handle the structure return ones that actually return, pass in a parameter that is the return value. And additionally, you still don't get your cross-references in the thing. So it's just kind of a hassle to try to figure out anything that's going on and programmatically do anything with these. So in Binary Ninja, it's not really much better. You do at least get your like selectors over here annotated that you can see what's being called, which is a little bit better than IDA, because IDA renames their parameters so you can't really see them, but you see the name of them, and all these colons get replaced with underlines, so you can't really like even really count them to see how many parameters the function is even going to take. If we look at the medium level IL view in Binary Ninja, it's a little bit better. You can see they collect the parameters. You can see where the selectors passed in, as well as the object pointer. I almost forgot the text or something. But it still doesn't know like what types these objects are. It hasn't propagated any of that stuff as well. So you're still left kind of trying to figure out what's going on there. And of course, there are no cross-references. And so it'd be nice if we could actually have some sort of view of the disassembly that actually looks more like Objective-C, so you can see what's happening. And that's kind of what I've put together, which I call Objective-C Graph View. So as a side-by-side, this is on the left-hand side is medium level IL, and the right-hand side is the Objective-C graph view that is built on top of medium level IL after collecting all of the information from the binary. And as you can see, we've got our actual structures propagated. We've got functions that are called in the blue. You can actually see those are those are linked to the functions themselves, so you can navigate through the binary as you would a normal binary that has just regular C functions. And the you can also see like the parameters are correctly passed in as well, and I believe, oh no, I didn't put the structure one on this one as well, but there is, it handles Objective-C message send stret, which is the one that passes in a pointer for the return value. And so there's also Objective-C message send super and super 2, which it also will tell you that those are the super ones. So how do we get this information? The Mach-O binary actually helpfully provides us with a lot of Objective-C sections, and these contain all of the metadata in structures that give you what you need to figure this all out. So the first things that we have to do are the class T and the class ROT. Those are the ones that define the actual structures for the classes themselves. And I left off method list T here. And then we'll also get the methods from method list. IVAR list is the provides a list of the offsets into the structure that are the different member fields, because why not abstract that layer for some reason? And then property list is pretty much the same kind of thing. It has information about the property, different properties on the Objective-C objects and their types and different things like that. So the class structure looks like this. The first two pointers are related to the type itself. So ISA is either going to be a pointer to a meta class object, which is the, I guess you could call it the type, or it's going to be null, I guess, which is indicating that it is a meta class, because meta classes are classes that you can pass into class methods. It's very confusing. Superclass is, of course, like regular objective-oriented programming, where it's the class that you inherited from, and you can kind of step up through those to find base class methods and things. I'm not going to talk about this cache thing, because that's something at runtime, but the important thing is this vtable pointer that points to the class ROT structure. And that is the structure that has all the information about the class itself, including the how big the class is and where it like starts in the object. So if it's like multiple inheritance, I think that offset can change. There's also the name of the object, their class, which is very helpful for figuring out type stuff. And then you've also got these 4 structures that give you the methods, the protocols, which are like interfaces, I guess, and the IVARs, which are the offsets to the fields and things, and then the base properties, which are kind of like IVARs, I guess. I didn't really understand what the difference between them is by doing this. But I found that when it calls properties in the disassembly, it just calls a function that then sets the property with the offset. So it's basically the same kind of thing as an IVAR. And then the method list, which was this one down here, the base methods. This is going to tell you the size of the method T object structure, and then how many there are for this particular thing, and then there's just like an array of that size after the metadata for it. And in this, you've got your name of the function, you've got the types, which is a string. I'll kind of show that in a minute. And then imp is a pointer to the actual function itself. And so you can see that there's a lot of levels that you kind of have to jump through here in order to figure out what method is actually being called by what things and like what types they are. Yeah, so I was going to go here. So this is kind of what these classes look like. The class T object, and then you can see there's a meta class version as well as a regular class version, and the B tables. Oh, and yes, you can also see is here in the regular class points to the meta class object, telling you that it's actually this kind of class. So if we go into the B table, then we get this class RO structure here, which you can see is got the name. Here's if we go to the base methods, we can click on that and see that there's all the different things. And this is what these type strings look like. So another thing that has to be done is actually parsing these type strings. And I don't think there's a really good one. So you can, yeah, so these will actually sometimes have actual class types in them as well, which is very handy for figuring out type propagation. Then the other thing is these Objective-C message calls. If we turn them back. We have them up. Okay, so anyways, you can see like this is what they look like in this view, but if we go back to the disassembly graph and go to it as well, so you get these Objective message sends, and the first thing that you have to do is then figure out what this type is. So going through to develop this, I collected these Objective-C message or class blah blahs, the symbols for these, and figured out that these are where it's passing in this class T type. And so then that kind of tells you that it's a class method that's being passed in, done instead. For other ones, once you figure out where the Alex and the inits are for various classes, you can then propagate those types backwards as well, which then starts allowing you to figure out what selectors go with which objects, and it then allows you to kind of figure out how to represent these Objective-C message send calls as the correct methods. Let me see if this one's got any. No. Okay. So we'll do a little bit more later as well. But let's see. Okay, so this is what it looks like when the I-bars are correctly figured out, because it creates, you can use the I-bars themselves to, which one was that one? Yeah, thank you. So in the disassembly, it's reading these I-bar offsets from this table, and then it adds those to whatever the class object is. So normally this would be just a RDI plus RAX, but once you identify that these are I-bars, set them to constants, the data flow propagation will actually propagate that through the disassembly, and you can see this app delegate object, which we created from the I-bars. It can tell which parameters actually being passed, and it then also propagates the class from that as well, so that you can see that this RAX is actually going to be an ANS window. I didn't go farther on the return values to then propagate those out, but that is possibly a future thing where figuring out the types of the return values, and then setting the function types to those as well. So then adding XREFs, I actually had to get them to add a new API to Binary Ninja in order to do this, because previously there was no API for a user adding their own custom cross-references for things. But now when you have a particular thing, like this function here, instead of just normally getting the cross-reference to the data section with the method T, you can see we now have the call instruction, which if we are actually in, we're actually in graph view, we hit that, we hit X. If we click on these, you can see it actually goes to the call itself, and you can see where it was called, and then you can click on this. And that's the new graph view. So that's kind of what we came up with for that. In the future, I want to add data renderers, which are classes that will allow you to update the linear view to show custom information. Actually, I forgot to mention that. Sorry. If we go to I added a data renderer for CF strings. So the CF strings now show up like this instead of as structures, so that you can see what the string is, and then it parses the different parameters or the different flags that are in the info field of the CF string. What's that? And it also has the XREFs for your strings. So if we there's one thing. I'm on the dev channel right now, and they don't have the unification with the navigation yet. So when you double click in linear, it goes to disassembly instead of graph view back again. But you'll notice like this parameter here for you shows this string. This is actually the CF string, and we've changed it so that it, instead of showing a pointer to the CF string, it just goes ahead and renders what the CF string actually is in this view. What I want to do is add some more data renderers for the classes properties to show the different attributes on a property as well, whether they're read-only or things like that. And there's still a few Objective-C methods that I don't handle. I added in things like release and retain, and then Objective-C message send super, and the super stret and the regular stret. But there's still a couple other ones, I think something to do with floats and stuff like that aren't handled. Eventually I want to integrate it into a decompiler that I've been writing on my Twitch stream that does a linear view, decompiled view of the medium level IL. And I'd like to then take the information in the Objective-C graph view and pass that into the decompiler instead, so that you get a decompiled Objective-C view, which would, I think, rival Hopper or actually be a little bit better, because there are some things that I handle that they do not. And then additionally, whatever pull requests I receive, so I've actually posted on the TrailBits GitHub. It's still private. I'm going to make it public right after this talk, but that's where you'll be able to find it and download it, and hopefully it's useful for people. And then we're going to do some demos. You want to skip this one? All right, this one was just showing like how many functions it finds and everything. It's really cool. But we'll go ahead and talk about these demos. And,
yeah, so we kind of mentioned it, that, anybody that's been in security and malware and threat and stuff, you have a grand idea, and sometimes things get a little derailed. So we had this great idea for this talk back whenever the CFP was, I don't even remember. And I had been looking at Schlayer. I just started kind of really digging into reversing the Mako of the final payload that does all the optimization stuff and cool stuff. And then we started, he started building the tool, and we realized that the code wasn't really very interesting. All the interesting stuff pretty much happens in the scripts before. So like, okay,
okay, here's some indentation stuff and things
and there's some strings and some stuff, but it wasn't really very interesting. So we're like, okay, I need to come up with another sample that illustrates something more interesting. And so we went with Windtail. I'd been looking at, I was like, I got to come up with something. I can't think of, like, what's something that has maybe like a simple decryption or something or other. And most of the Mac malware, it's a lot of shell scripts and stuff. Like the actual Makos a lot of times aren't really doing a whole lot. That's super interesting. So if you're not familiar with Windtail, some of you that are might have noticed that the things he was demoing earlier with the UP function, that was actually the Windtail sample. Basically, Taha Kareem from Dark Matter did a presentation on this back last year in Hack in the Box Singapore. That one's also on YouTube. You can search for it if you're more interested in this. He goes into more detail about the whole APT campaign that was targeting the Middle East and things like that. So if you're interested in that aspect of it, he goes into a lot of detail. They used basically a unique exploitation technique that leveraged custom URL schemes, which Patrick actually wrote about in his blog. That goes into a little bit more detail. And I think I posted the link for that as well. It creates a login item, typically for persistence. There's a hard-coded AES key. So basically the strings are base64 encoded and then AES encrypted. So we wanted to kind of just show that. And then I just wanted to mention really quickly, because this is part of the rabbit hole that I went down with Schlayer and Windtail. And when I was looking into Windtail, I noticed that this bundle identifier, if you're familiar with these, this bundle identifier was the same as I dug up some samples from back in 2014 that seemed to be attributed to Laoshu malware. And it's the same bundle identifier, which I thought was interesting. I still haven't had a chance to actually dig into that. But then this open URL string down here is actually part of that custom URL scheme, and it's actually shared with all of the samples that I've seen with that are attributed to Windtail. So that's just a quick intro to Windtail in general, and Josh is going to share some things. That's the blog. But if you just Google Objective-C Windtail, I think his blog is the first result that comes up. So. Yeah, and you can actually, you can get the sample from there. So if you want to play around with this in Binary Ninja, you totally can. So I'll go ahead and close this and we'll start fresh. I can't turn my brightness up. Okay, all right, well, it's slightly dark, but we'll get through it. All right, so we bring it up initially, and this is. No, I'm in binary. Yeah, I'm in binary ninja right now. So you'll see, like, there's just a bunch of functions. Nothing really makes any sense. I mean, we can kind of click on these, and you'll see some Objective-C message send as well. And there's like our UPs and things like that. But if we go ahead and run the script, you can see it just starts populating everything. And then we can switch to the graph view, and this UP function is the interesting one because it has our AES decrypt with passphrase. You'll notice that it's orange because it couldn't tell what the type of RDI is. But if coming in here, another function I think that I figured out that this is actually a NS data pointer. And as soon as it knows the type, it knows what the function is. And you'll notice that there's a couple of XREFs here now that would not have been there previously, and we're going to use those to actually make this a little bigger. We're going to use that to actually automate decrypting the AES strings by finding them. So we're going to go ahead and just kind of
run some of that stuff. It's going to so I'm going to go ahead and open the file from the headless mode with Binary Ninja. That's what the binary view type is here. And then I'm going to run the plugin from the command line here and wait for that to finish. It just takes a couple seconds, usually. There we go. Okay. And then a couple other things just to set up. I'm going to go ahead and get the type of the CF string, figure out where the offsets are for those, and then set up a binary reader for that. And then the get buffer function is just a helper function that lets me read out the values that I need in order to figure out the whether or not it's Unicode, whether or not it's where the buffer is, what the length is, and then actually read out the buffer itself and return that. So we'll add that. And then next up is a function that just decrypts the AES strings. So I was having an issue, and I think I could have done this with a transform in Binary Ninja, but I was having issues with the key not working. And so I tried using PyCrypto instead, and was also having the same issue, so it was not Binary Ninja. But I just didn't have time to switch it back. So we're going to use this function here is going to take the code refs of the function that's actually calling the AES decrypt function, and then figure out what the key is. Oh no, we already passed in the key. This is going to take the parameter that has the encrypted string and pull that out of the function that's calling the function that calls AES, because it passes in, it comes through UP here, is the one that calls the AES decrypt string, but then the function that calls UP, Yon, is the one that actually passes in these base64 encoded strings. So that's what we're getting in decrypt AES strings. We're pulling the actual encrypted string, going ahead and taking the key that we passed in, base64 decoding it, and then decrypting it as well. So we'll run that one. And then finally, we're taking advantage of the plugin here by using get code refs to get the cross-references for the function by passing in its address, rather than having to like parse the structures and figure out where its selector is and which one it is, and then getting the code refs for that. So this makes it a little bit easier for you to figure out like what's actually going on with this code. And from there, we're just getting a medium level IL. We're then going to figure out what the caller is by getting the second or the third parameter for the key. And then we take that, we pass it into the pointer for that into get buffer, which then does all that stuff earlier, reading the CF string and parsing that out. And then I kind of commented here because I wanted to be transparent. They, in AES decrypt with passphrase, in AES decrypt with passphrase, they actually take the UTF-16 string and pass it to UTF-8 string, which then encodes it in UTF-8. For some reason, Python will not encode the UTF-16 string in UTF-8 the same way that the Objective-C apparently encodes it, which is really strange, and I could not figure out what was happening. And so I ended up just taking it from a debugged version of the binary after accidentally infecting myself like 6 times. And finally got it and just went ahead and put it here because the key is hard-coded.
This is why it's good to know malware analysts to say
Yes.
this is where the login item is and the other stuff.
Yeah, she knew where to actually remove it, so I was able to like remove it every single time. But yeah, fortunately, it wasn't too complicated. And then we go ahead and take that encryption key, pass it into decrypt AES strings, and you can see we now have a bunch of decrypted URLs and other things that they use in the binary. So yeah, that's it. Questions? I know. Yeah, I was pushing it to try and get to 6. We made it.
Awesome talk. I'm not gonna lie, I wish I had this when I was doing some of the analysis. That would have been really awesome. So we have time for 1 or 2 questions, and then some final announcements, and then we will be done for today. So, any questions for Erika or Josh? I'm sure they'll also be at the party, so you can.
Yeah, or Twitter.
Yeah, and last pitch is that I stream on Tuesdays and Thursdays playing. It's a show called Effing Around with Binary Ninja. And I literally just F around with Binary Ninja and write tools. I'm currently writing my decompiler. So if you're ever bored and want something to watch on Tuesdays and Thursdays, 3 p.m. Pacific time.
Also, I meant to put up your GitHub, but it's the code's up on GitHub, Trailbits GitHub. And
Oh yeah, I linked it earlier in the. Oh right, yeah. Yeah, it's Objective-C Graph View on the Trailbits GitHub, and I'll make that public in just a couple minutes.